Dear world, this is Deze, Zhang, General Co-Chair of BDTA 2020 from China University of Geosciences, Wuhan, China. Glad to meet you online and welcome to BDTA 2020. Due to the safety concerns and travel restrictions caused by COVID-19, EAI BDTA 2020 will take place online. As you may know, this year we actually have the 10th edition of BDTA. BDTA targeting at big data technologies and applications started from Hong Kong, China in 2006 and has been successfully held in many different cities across many different countries, such as Suzhou, China, Vico, Equins, Italy, Seoul, South Korea, Exeter, Great Britain. Now we come to the 10th edition. I am glad to serve as the General Co-Chair of this year's BDTA. Take this opportunity, I would like to express my sincere appreciations to all the steering committee members for their valuable suggestions and guidance. I also would like to thank all the organization committee members for their hard work and great efforts to this conference. I also would like to thank EAI office staffs for their professional work to support this conference. In this year, we have received 21 papers in total. These papers are from different countries such as China, Australia, Korea, Portugal, America, Greece, France, and Philippines. Here, I would like to take this opportunity to thank all the authors for their interesting and support to BDTA 2020. After peer review, for each paper, we have 3 reviews. We finally accepted 10 of them. The acceptance ratio is 47%. These accepted papers also span many different countries. Due to COVID-19, unfortunately, we cannot have an online international meeting, but only a virtual one. Due to the wide span of the time zones, it is hard to arrange a live online meeting. So, we require all the authors to upload their presentation first and publish them in a live stream manner. Even we could not meet in person and interact directly, EAI provides us a unique interactive way for any question to each presentation. Online Q&A is reserved for participants and supported for weeks, even after the conference ends. So, if you have any question regarding the talks, please feel free to propose online according to the EAI online conference instructions. This year, it's our great honor to invite Professor Changqin Huang to give a keynote speech about their research achievements on applying big data to education. Besides, we also have 2 sessions with 10 presentations from the authors, covering a wide range of topics related to big data technologies and applications, such as machine learning, security, knowledge graph, education, industry. Hope you all will enjoy this conference. Thank you.
Dear ladies and gentlemen, let me welcome you to the EAI BDTA 2020, 10th EAI International Conference on Big Data Technologies and Applications. I'm Aleksandra Szczeciejowska, the EAI Conference Manager of BDTA 2020. Unfortunately, due to the virus, I am not able to meet all of you in person, so I am using this opportunity to address the organizing committee, the keynote speaker, the authors, and the participants on behalf of EAI. First of all, I would like to thank all of you for being a part of this conference and for your involvement with EAI. Above all, I would like to express my gratitude to the General Chairs, Deze Zhang and Changqin Kang, as well as the Program Chairs, Rui Hou and Huang, for their hard and excellent work throughout the whole process of the conference preparation. During today's event, you can actively participate by joining the Q&A on Slack through a link that you can see below this video. Upon accessing the EAI BDTA 2020 Slack workspace, you can enter the channel called Discussion. To sum up, it is our honor to organize this year's edition of BDTA conference. I hope you will have a wonderful time during this event and that you will follow the next edition in 2021. We will keep you posted, and the news about this event will be available on the conference website. Should you be interested in being a part of the organizing committee or the technical program committee, please do not hesitate to contact me at my email address below. Similarly, if you are interested in discussing other possible cooperation, organizing a conference or a workshop, please contact me at my email address as well. Thank you for your attention and enjoy EAI BDTA 2020.
Hi everyone, my name is Michal Dudic. I'm the Community Manager at EAI, European Alliance for Innovation. It's my pleasure to welcome you at this conference and say a few words about who we are and what we can do for you and your research career. In short, EAI is a global community for a greener, healthier and smarter world. As of today, we are home to more than 60,000 members from 167 countries, and we reach out to tens of thousands of subscribers. As an organization, we are non-profit from day one, and what is most important to us is that we remain open to all researchers from all around the world thanks to membership that is completely free. We organize more than 100 events annually, such as this conference, and we do so in publishing partnership with Springer. I said in the beginning that EAI is a community, so let's talk about what that means and what it means for you. To put it briefly, we give our members a platform that builds their research. We do it with 3 main online community services where members come together to help each other write a better paper, get an objective review, and get recognized fairly. The 3 services in question are EAI Compass, Community Review, and EAI Index. Firstly, EAI Compass is an online app where you can meet and connect with new colleagues and get feedback on your paper as well as your presentation. In addition to that, it lets you download all full papers that will be presented at this conference, and you can vote on your favorite presentations as well as see everyone who is here and connect with them. You can do this right now if you go to EAI Compass website, compass.eai.eu. Next, we are improving the classic conference review process with community review. It has already been in use at all our events since 2019, and we were very excited to hear a lot of positive feedback from program committee members regarding the reliability and the speed of the community review. Let's talk briefly about what community review does. Essentially, it is a website that shows abstracts of papers that are right in the middle of the review process, as long as the authors allow it, of course. And all EAI members may then bid to review specific papers. When they submit their bid, they put in their bio and their qualifications, which are sent to the program committee, who can then decide whether or not this bidder is qualified to review the paper they bid on. This relatively easy access to review opportunities means that bidders really need to put their best foot forward if they wish to be selected, which improves the quality of the entire review process. At the end of the day, this benefits you, the author. And last but not least, let me tell you a thing or two about EAI Index. EAI Index is our credit-based evaluation system that we rolled out this year to all of our conferences and journals that allow you to climb the global ranks of EAI community and get recognized for your work. It calculates a number value for most actions you make, such as getting your paper accepted or submitting a review, and these numbers accumulate for 12 months. At the end of this 12-month period, we put together a ladder of all EAI members, and the ones at the top receive a nomination to one of the membership ranks: senior member, distinguished member, or fellow. For each action that is eligible for EAI index credits, we'll look at the quality of your action as it was evaluated by another member of the community, such as, for example, the review score of your submission. To make sure that the system is fair to newcomers, every 12 months the credit count gets erased, the ones at the top receive their nominations, and every member starts at 0 for the following 12 months. And finally, Smart Submit is a collaboration feature that is coming later this year. It will allow you to submit your research ideas and your work in progress abstracts to get the kind of help and feedback you're looking for. Maybe you are looking for co-authors, maybe you would like to find a mentor or a mentee, or maybe you want to find out how the community feels about your idea. This is what Smart Submit is designed for. Ultimately, it's about helping you write a better paper and increasing your chances of getting accepted. Again, we will be launching this feature later this year, so stay tuned. And so I'm going to leave you with many different ways to get engaged at different levels. There are lots of opportunities in many of our events and publications, which means many ways to connect with people and collaborate. You may learn more about everything I just talked about at our website, eai.eu. These services exist to help you and to make your lives easier, so we encourage you to send us your comments, ideas, and feedback to community@eai.eu. And if you're interested in volunteering and contributing, you can let us know at the same email address. Don't forget that you can use EAI Compass to vote on presentations in real time to determine which ones are the best, as well as to download all full papers that will be presented today. Just make sure that you log in using the same email address as the one you used to register to this conference. Thank you very much for your attention. Please enjoy the conference, and I hope we will see everyone online soon.
Hi, ladies and gentlemen. I'm Changqin Huang from Zhejiang Normal University. I feel really honored to have this opportunity here to give a talk on big data technologies and applications. The title for my talk is Big Data-Driven Intelligence in Education, Research and Practice. I will present 7 parts in this talk that includes new opportunities, basic requirements, service mechanism for educational big data, application scopes, principles and methods, application practices, and the last part, problems, challenges, and trends. First, let us briefly revisit the new opportunities on big data and AI. As we all know that big data concepts, as well as their techniques, have received careful attention in the past few years. On the other hand, artificial intelligence as a hot topic also has been widely studied in many areas and domains. It's important that AI needs big data to establish its intelligence and provide better services for human beings. According to the government policies, AI and big data now are offering us new motives, new opportunities, and new ways from different perspectives. That is to say, with the support of AI and big data, intelligent education is expected to improve the effect of education in resource sharing, personalized learning, and intelligent teaching. So, what are the domain issues around big data, AI, and education? Here, we list a few. For example, the technical bottleneck like real-time data access, semantic fusion, dynamic analysis, and the potential challenge that includes complexity of education and teaching, and the deep integration of AI technologies and education. So overall, we need to highlight 2 points here. The first one is the deep integration of AI technologies and education helps to realize large-scale, customized education and process service. Then, education driven by big data presents the new characteristics of connection of some theories and the intelligent technology and application. To summarize, there are many new opportunities towards how to advance greatly the research and practice based on the theories and technologies of big data in education. For example, it can realize personalized and intelligent teaching management and achieves iterative progress. Furthermore, it can provide more database and educational practice scenarios and constantly iterate and update to achieve technological innovation. Next, I will talk about some basic requirements. Technically, since applications in education domain is human-based, like students, teachers, faculty managers, etc. To better facilitate the application of AI and big data in education, we need multi-theories and fundamentals to promote the meaningful outputs in education, rather than relying merely on only computer science technologies. In general, 3 theories that includes cognitive science, behavioral science, educational psychology are required to use AI and big data techniques to meet the educational demand. So in detail, what are the demands of educational intelligence? We summarize that in 3 aspects, like learning, teaching, and management. So first, cognitive theory for learning. That means teachers should present abstract knowledge hierarchically to help learners form meaningful cognitive structure. Then, humanistic psychology for teaching. For example, teachers should be learner-centered and give personalized intervention and feedback in time. And the last one is behaviorism theory for management. For example, teachers need the ability to analyze the data of the whole learning process and guide the learning process individually. In the third section of this talk, I would like to introduce some basic service mechanism of educational big data. First, let us talk about some characteristics of educational big data. Generally, according to the application scenario and application domain, we can divide the educational big data into the following categories, like procedural big data, generative big data, and physical big data, and others. For example, the procedural big data may include teaching activity data, teaching research data, education management data, education evaluation data, like academic achievements, state tests, and some comments from the students. That also includes learning behavioral data and some online interactive data. So the generative big data may include some online courses, VR and AI, platform and website. And some physical big data, it's logical to see that like EEG signal and eye tracking and facial expression of the students. Of course, there are also other types of big data in education, like some cross-domain data, say for example, cultural habits, social relationships. So how to design the intelligent service? As shown clearly in this diagram, first we start from educational big data that involves the learner, teacher, administrator, and other objects. Then we need machine learning techniques here, like traditional ones to deal with, for example, classification, regression, clustering, and some relationship mining. And also the deep learning techniques like convolutional neural networks, recurrent neural networks, and graph neural networks. Once we have obtained the data analysis results, we can build a pool of educational knowledge that is induced from the educational big data rather than purely from the of experts. Then this knowledge can help customize the service for educational intelligence on teaching, management, and learning. Finally, we can get timely feedback and make dynamic adjustments to the data level, the initial stage. As we can see that the whole process is working in a closed loop manner rather than an open loop. The fourth part I would like to present here is the application scopes. In particular, the application related to educational intelligence includes the presentation of knowledge and ability structure, like the knowledge map is used to determine learners' learning state and realize personalized learning support. And the second aspect is intelligence, diagnosis, and recommendation. Say, for example, how to use AI technologies to identify students' personality characteristics and learning needs, and how to recommend appropriate learning resource to the students. The third point is intelligent assistance system for learning. Say, for example, how to develop an assessment system based on brain function network and ability module. The fourth point is educational robotics. See how to use educational robotics to provide state and programming education. We can also have some applications in teaching and research. See, for example, the intelligent tutoring system and the intelligent question answering system and the automatic marking system. So for teaching and research, we can have some applications like summary generation and instructional design generation. We can also have some AI-based application in education like the educational evaluation. For example, adaptive evaluation. See how to provide career suggestions to help learners plan for growth and development. We can also have some student management system based on AI. See, for example, oral practice and assessment, learning analytics, and classroom management, like automatic classroom observation. Educational administration may include course arrangement, career planning, attendance. Say, for example, we build some AI system to do this voice recognition or facial expression recognition. And we can also do some intelligent planning and application service. So in terms of the university or campus management, we can have some application like enrollment and consultation, security and library management. Say, for example, some learning resource like book recommendation service. We can also have some intelligence systems, including feedback mining, process design, process supervision, and decision making. So all these applications have used this AI and big data techniques. Apart from the above application scopes, there are some intersect ones that we did not list here. Next, I will introduce some principles and methods towards this direction. As we mentioned earlier, educational intelligence is somehow a special case since the service targets are human beings. That is, the students, the teachers. So we need to specify some principles here. First, supported by learning and teaching theory. That means educational intelligence driven by big data needs to be supported by learning or teaching theory and regarded as a key part of model development in teaching. Secondly, supported by adaptive big data learning model. For example, one needs to put forward accurate technical requirements for machine learning applications and really understand the meaning of the prediction results. Third, service intelligence based on personalized educational demands. And the fourth one, collective intelligence supported by Internet. As widely acknowledged that, relying on international Internet organization structure, collective intelligence is jointly built by connecting all knowledge, wisdom, insights of individuals. That's the meaning of this collective intelligence. So, in summary, we highlight 4 points here. First, hybrid educational intelligence based on human-machine cooperation. That is important. The second one is knowledge fusion innovation based on interdisciplinary. The third one is life cycle intelligent education ecosystem intersection. The last one is data ethics supported by utility maximization. Once we are all clear about these principles, what kind of method we can use to facilitate the educational intelligence? Here we give a big picture that covers both the traditional machine learning techniques and the deep learning technologies. Say, for example, for the classification problem, we can have some traditional methods like decision tree, SVM, this is supportive vector machine, and the Bayesian network, and KNN. And we can also apply the widely used artificial neural networks that is in deep learning. So for the task of relation mining, we can have the methods like multiple regression, hidden Markov model, association rules. For the task of clustering, we can have a lot of options. Say, for example, the k-means. It can merge the input data according to the central point or hierarchical mode. But it's a kind of unsupervised learning. So some deep learning techniques that are widely used in this domain. Say, as we mentioned earlier, the CNN is convolutional neural network. It can be used to learning resource recommendation, abnormal behavior recognition, like image recognition, voice recognition, and something like that. We can also use these recurrent neural networks, for example, LSTM, this long short-term memory network, and GRU, the recently proposed one. So it can be used to learning path recommendation, as we will show later, and continuous performance prediction, like test classification. And the recently developed graph neural networks, we use GNN for short. It can be used in the problems like semi-supervised classification. For example, the graph node classification and the supervised classification like graph classification and some relational reasoning. So in summary, we have a lot of options to choose which kind of methods to build an educational intelligence system. Next, I will present some application practices to better show how AI and big data techniques can help us to build a system. The first case study is called Fine-Grained Student Learning Performance Prediction. In this study, we deal with the problem of fine-grained student performance prediction in an online course using deep learning-based long sequence generation. By formulating the student's feature as a matrix where elements in certain parts are missing. Based on this advantage, an adaptive sparse self-attention network is proposed to generate the missing values and find the most correlated components from the past learning stage, so we can make the final prediction of the fine-grained performance in this e-learning space. So here is a brief introduction of our framework. The first part we do this feature extraction, and then we use this obtained feature extraction to build this classification model. Here we have used this sparse self-attention network. We proposed these algorithms. We also have compared several baseline methods to show that our proposed fine-grained models can produce more stable and better performance. As a real case study, we also implement the algorithm in 2 real-world e-learning platforms, like the World UC platform and our developed Liru online courses. The experimental results also demonstrate the effectiveness of our proposed methods. Another work is for personalized learning four-pass recommendation. Here are our proposed models. A novel framework for building personalized learning four-pass recommendation model, and extended LSTM module feed with clustering data that can process smoothly the e-learning stream data. As we all know that discovering useful hidden patterns from learner data for online learning systems is very valuable. So for that expression, we developed a LSTM module based on this clustering data, not the original data. Then personalized learning forecasts can be selected from the results of the path prediction. We also have these algorithms. The first one is recommendation pre-treatment using clustering, as I mentioned before. And the second one is algorithm for optimal path acquisition. So in this study, we also have a series of experiments that we can demonstrate that our model outperforms some baseline models. The last case study is teaching analysis and the intelligence evaluation system that pay careful attention on 7 aspects as I listed here. So after addressing these aspects, we can show the data analytics and visualization for the whole learning process. So the last part of my talk is about the problems, challenges, and trends. We should think carefully how to boost the educational intelligence by virtue of big data in terms of 3 perspectives, like data, service, and the model, together with the principles we mentioned before to implement the existing techniques or develop new technologies in big data and AI. In summary, we have a few points to highlight, like spatial and temporal global data acquisition. For example, in some cases, offline educational data cannot be collected effectively and comprehensively. Another point is that cross-domain semantic integration and standardization. For instance, establishing a unified data collection standard and technical specification for education process is necessary for the semantic level information integration. In addition, we should make a clear mind on comprehensive AI technology application and knowledge construction. Combine the specific learning or teaching theory and select the targeted and suitable machine learning algorithm to help to process the corresponding educational data and construct an interpretable and intervenable analysis model. Also, we need to pay more attention to quantitative and qualitative education and understanding calculation. In other words, based on the combination of quantitative research and qualitative research, it's one of the challenges to construct a calculation method of educational understanding with transfer and cognitive expression. Finally, intelligence evaluation of driving innovation based on big data. For example, the effect evaluation mechanism of driving innovation has also become a problem and a challenge of educational intelligence driven by big data. That is all what I would like to share today. Thanks for your listening. If you have further questions and also some interests on the recent publications in the case studies, please feel free to contact me in any case. Thank you.
Hello, everyone. I'm very glad to have this chance for attending this conference and presenting our recent work on the topic of constructing knowledge graph for prognostics and health management of onboard train control system based on big data and XGBoost. I'm Zhang Liu, the first author of this paper. On behalf of our research group in Beijing Jiao Tong University, my presentation includes 4 parts: research background, system and architecture, case study analysis, and conclusions. For the development of railway and related techniques, it can be seen that railway transportation plays an important role in the national transportation systems. China is experiencing a rapid development for high-speed railway in the 21st century. There has been an important plan for an enhanced high-speed railway network in China with 8 horizontal and 8 vertical lines. In addition, a complete technical system has been established based on the experiences in recent years, including train dispatching, traction feeding, permanent way engineering, disaster prevention, system maintenance, passenger service, high-speed EMUs, and rail signaling control. Main characters of high-speed railway include the large-scale, high-speed, and critical safety requirements. That means any of the potential danger of small fault or failures may cause very serious consequences for the operation of high-speed trains, and thus it has to be a big concern about the safety, which is the heart of all the operation-related activities in railway transportation. Presently, the railway industry has taken a great effort and is focused on the exploration of advanced ABCDE technologies in the new generation train control systems, where the ABCDE represents artificial intelligence, blockchain, cloud computing, big data, and everything is connected. Specifically, the big data technology has been applied in many aspects of railway operation and maintenance, including railway condition monitoring, train delay analysis and prediction, passenger route choice and demand forecasting, railway events and accident analysis, and optimization of time scheduling. The rapid development of ABCDE technologies and their implementations encourage us to utilize them in the assurance of safety for railway transportation. For the operation of high-speed railway, there are several key components in the onboard system, including the traction drive control system, brake control system, traveler information system, and the train network system. Among these subsystems, the train control system is responsible for setting up non-conflicting and safe routes for the trains, defining the safe limits of movement, and transmitting instructions or commands to the train drivers. In the operation of the high-speed railway, fault diagnosis and equipment maintenance for train control system play a significant role in ensuring the safety and efficiency of the trains. Furthermore, under the fail-safe principle, faults or failures in the train control system may result in function degradation and fault isolation within the fail operation space, or even the service termination with the fail stop space. The Chinese train control system specifications are based on the RAMS concept, which indicates the reliability, availability, maintainability, and safety. Thus, assurance of the safety has to be achieved with a consideration that the full life cycle of the train control system has to be covered. In order to effectively extend the system's life cycle, several new maintenance concepts have been proposed and utilized in many industrial branches, particularly the prognostics and health management technique, which aims to carry out fault detection, condition assessment, and failure prediction, has been successfully implemented in railway. However, conventional corrective maintenance and time-based maintenance strategies are still adopted in the operation management of high-speed train control systems in China. Due to the limitations and conservative characteristics of the in-use maintenance principles, there is still space for improving the utilization of remaining useful life of systems, which is of great importance to optimize the cost efficiency of maintenance activities from a full life cycle perspective. The condition-based maintenance mode, we call the CBM, can be realized based on the enhancement of state monitoring conditions to the whole system and its components. The big data based on the accumulative data logs from the train control equipments enable the opportunity to investigate the fault causes and the development characteristics under a rich information condition, which encourage us to establish a specific decision support mechanism for the condition-based maintenance of the onboard train control equipment under the PHM framework. Here, we can see the main technical architecture for railway applications. Based on the theoretical basis like the system safety assessment, fault diagnosis, and reliability evaluation, some key issues will be investigated, including the analysis on multi-fault cause mechanism, fault risk quantitative assessments, and real-time reliability evaluation. Technical development and system construction will be carried out to realize a deep utilization of the big data condition, and thus the system deployment and application can be achieved. Taking the 200H onboard equipment for high-speed railway as an example, system manufacturers have concern that the data logging function for diagnostic purpose by using a PC card in the data recording unit is necessary. The maintenance staff will download the log files when the train finished the planned operations. By using specific software tools, it is usually easy and intuitive to review and inspect the practical running status of equipment, actions, and the automatic train protection units, manual operation activities of the drivers, and the reported fault events. We proposed and developed a big data platform aiming at enabling a data-driven CBM framework by utilizing all the historical operation data, the association knowledge and the accuracy, regularity of the different faults for the onboard equipment can be effectively obtained. This figure shows the architecture of the big data-based platform for data management and CBM decision assistance. It can be found that the platform consists of 4 layers. The first one is the field operation layer. The onboard train control equipments record data logs to PC card during the field operation. Data acquisition based on this layer provides the foundation to reflect the equipment status in the time domain. The developed knowledge graph and fault probability prediction results will provide feedback to this layer to affect the application of this onboard train control equipment. The second one, the data collection layer, is in charge of extracting and transforming raw data sets periodically. Specific tools and program scripts have been developed for automatic pre-processing, including data classification, format transformation, code conversion, and data cleaning. The characteristics corresponding to the fault labels are prepared for incremental updating of the data storage and the following data processing operations. The third one, in the data storage and management layer, the Hadoop distributed file system we call HDFS is adopted as a data storage framework. 3 high-level servers have been involved in this platform under a master-slave architecture. One is configured as a name node and the other two servers act as data nodes in the Hadoop cluster. The last one is the data processing layer. Hive is utilized as a data querying engine for the large-scale data storage stored in the Hadoop. The Hadoop user experience interface enables us, the users, to access all the data files stored in the HDFS and have based data processing results. XGBoost-based machine learning system is introduced for tree boosting to derive the feature importance scores for generating the knowledge graph under the Spark framework. With this platform, the knowledge graph generation requires the identification of all the related features in the dataset. The identification of features and labels and the adopted algorithm are summarized as follows. The features can be divided into 7 categories, including time information, identity information, train operation condition, running state, action status of key components, driver machine interface data, and system parameter. In this paper, the XGBoost algorithm is adopted to build the knowledge graph based on big data, which is one effective supervised machine learning algorithm to realize a scalable tree boosting system. By training the XGBoost model, a series of decision trees can be obtained and used in classification with specific labels. Utilization of the second-order Taylor expansion to a loss function and normalization against the overfitting make it different from conventional methods like the gradient boosting decision tree solution. As the last step, the value of feature importance by the models provides us a reference to quantitatively evaluate the content of contribution by each feature to a functional fault label, with which the knowledge graph corresponding to a specific fault can be derived. Since 2015, field data log files of onboard train control equipment used in practical railway operations were collected to build the big data-based system. In the laboratory, the big data platform was established using a master server and 2 slave servers, as shown in this figure. There had been over 18,000 log files of the 20H onboard train control equipment, and the data amount almost reached 1 terabyte. For fixed number, 500 has been adopted for simplicity in generating the decision trees in the case study. Statistical results of different faults and the corresponding feature importance data enable us to construct or update the knowledge graph. Here we show the model training results. A case study is performed using the field data sets of 200H equipments from January to June in 2017. The figures in this slide show the results of feature importance corresponding to the controlling fault mode. It can be found that not all the features are covered in the presented importance sequencing result. Based on the significance principle, only 33 major features from the whole feature set are considered in the feature importance sequencing and distribution analysis, since they achieved a contribution over 97% to the target fault mode. In the left figure, clearly shows the distribution of importance by each individual feature in the subsets. In addition, the red feature illustrates the differences among the 33 major features according to the normalized value of feature importance. Based on the result of feature importance sequencing, the knowledge graph for the controlling fault mode is derived using the selected major features. Using the open source eChart visualization tool, 33 features nodes are integrated into this knowledge graph around the central node with a label controlling faults. The knowledge graph clearly demonstrates a visualization interface to the users, which effectively reflects the inherent knowledge from a large dataset. The fault relevance information from the graph can be provided to the specific engineers or staff to make decisions for adjusting the maintenance plan. So we can get the conclusion of the whole research work. A data-driven framework is presented for constructing the knowledge graph in pursuing the prognostics and health management of onboard train control system. A big data-based platform is designed and established to realize the storage and management of accumulated data files in the field operation. The XGBoost algorithm is adopted to enable the model training with respect to the specific fault modes, which derives the knowledge graph. In our future work, comparison analysis will be carried out based on the multiple datasets within different time ranges. Different training models will be used to perform fault probability prediction to realize a tight connection between the models and decision-making results for maintenance works. And more types of onboard train control equipment will be taken into account to enhance the practical operation and maintenance activities. That's all my presentation. Thanks for your attention. Thank you.
Hello and welcome to the presentation of the Big Data Intelligence Marketplace and Secure Analytics Experimentation Platform for the Aviation Industry. I'm Dimitris Miltiadou from UBTech. The aviation industry has been embracing digital transformation ever since the digital revolution began. It is driven by the rise of cyber-physical systems and sensors and their massive deployment in airplanes, the next-level interfaces in the airports, and the connected aircraft airport aviation ecosystems. It should be noted as an example that the Airbus A350 aircraft model is equipped with more than 50,000 sensors on board, collecting 2.5 terabytes of data per day. In this sense, there is a ripe for innovation in the form of big data analytics across the aviation industry and all interlinked industries such as tourism, security, transport, etc. At the same time, leveraging big data technologies comes with new challenges for effectively handling information security of massive and rapidly evolving heterogeneous data. The nature of the big data analytics and its effective execution introduce multiple security threats, such as the discovery of private or confidential information and unauthorized access to data at storage or data in motion. For this reason, it is acknowledged that the aviation industry is reluctant on the adoption of big data analytics due to security and privacy concerns. Our contribution is a big data-enabled platform that holistically handles the complete big data lifecycle within a novel aviation data and intelligence marketplace that enables data exploration, blockchain-empowered sharing, and brokerage. It offers a trusted and secure sandbox analytics, a workspace that effectively, securely addresses the critical barriers of the adoption of big data in the aviation industry and enables aviation-related big data scenarios for EU-based companies, organizations, and scientists. Additionally, it offers a holistic security approach that capitalizes on the latest advancements and modern technological breakthroughs in the area of big data, data analytics, and security in order to accommodate the needs of the data analytics stakeholders for secure data upload, access, sharing, processing, and data analysis of big data. The Icarus platform aims to provide a big data-enabled platform that aspires to become a one-stop shop for aviation data and intelligence marketplace that provides a trusted and secure sandbox analytics workspace, allowing the exploration, curation, integration, and deep analysis of original, synthesized, and derivative data characterized by different velocity, variety, and volume in a trusted and firm manner. The Icarus platform builds a novel data value chain in the aviation-related sectors towards data-driven innovation and collaboration across diversified and fragmented industry players. In this sense, the Icarus platform offers a scalable, flexible, big data-enabled environment that provides secure and trusted data preparation and data upload, data exploration, data sharing and data brokerage, and finally data analysis, execution, and visualization generation. The Icarus platform architecture adapts security and privacy by design approach for increasing the security and privacy and data protection across all tiers of the architecture with the end-to-end encryption that is imposed in all datasets stored in the platform and secure decryption process for the effective data sharing of datasets. In this sense, the Icarus platform integrates the secure experimentation sandboxes that enable the provision of sophisticated environments that can completely guarantee the safety and confidentiality of data, allowing any interested party which utilizes the platform to conduct analytic experiments in closed lab conditions. The Icarus project has received funding from the European Union's Horizon 2020 Research and Innovation Programme. The Icarus architecture is a modular architecture composed by 22 key components conceptually organized in three main tiers. The first tier, the on-premise environment, performs the data preparation steps on the data provider's environment to prepare the data provider's private or confidential datasets in order to be uploaded in the platform based on the instructions provided by the core platform. The second tier, the core platform, performs the core operation of the platform, providing the single user interface of the platform, and it compiles the instructions that are executed by the two other tiers, the on-premise environment and the secure and private space. And the final tier is the secure and private space that provides the trusted and secure sandboxed analytics workspace for performing advanced analytics and visualization as managed and orchestrated by the core platform. This is a graphical representation of the Icarus platform architecture. At the left stands the on-premise environment that is operating on the on-premise environment of the data provider. It is composed by the on-premise worker that orchestrates the data preparation tasks, the mapper that maps the dataset entities to the Icarus Common Information Model, the anonymizer that performs the anonymization tasks, the encryption manager that will encrypt the data prior to being uploaded to the platform, and the decryption manager that decrypts the data during the local downloading process. In the middle stands the core platform with services responsible for all the core operation of the platform. It's composed by the master controller that provides instructions to the worker of the two tiers, the data handler that handles the data-related operations, the data license and agreement manager that controls the data sharing and data acquisition of the datasets via smart contracts, the secure storage that provides the storage capabilities of the secure and private space tier, the Icarus storage and indexing that provides the storage and index capabilities of the core platform, the policy manager that handles all the data access control of all the resources of the platform, the query explorer that handles the data exploration aspects of the platform, the recommender that provides data recommendations to the user, the data preparation manager that enables the data manipulation of the stored datasets, the analytics and visualization workbench that enables the design, execution, and monitoring of data analytics and visualization, accompanied by the BDTA application catalog that is the repository of these designed analytic workflows. We also have the key pair administrator that handles the symmetric key exchange between the data providers and the data consumers, and the resource orchestrator that enables the provisioning of the secure and private space tiers. The added value service on the top, we have notification and usage analytics. On the right stands the secure and private space. It's composed by the secure space worker that orchestrates the data analytics task execution, the decryption manager that decrypts the datasets prior to being used for the analytics execution, the job scheduler and execution engine that performs the actual data analysis, execution utilizing the private instance of the execution cluster that is the cluster computing framework of the platform. And finally, we have the encryption manager that detects the encryption of the produced results. Going deeper on the components, the details of the components, on the on-premise tier, we have the on-premise worker that performs the local execution of the job as instructed by the core platform, utilizing the deploy service on the local running environment and the on-premise environment. The mapper generates the mapping from the new data to the common aviation data model based on the user input from the user interface in the core platform. It undertakes also the data transformation to the common aviation model. The anonymizer provides the means to deal with privacy issues and protection of sensitive information with a variety of anonymization techniques. The encryption manager, it encrypts the data before they are securely transmitted, uploaded, and stored in the core platform. It follows a symmetric key encryption based on the EAS 256 symmetric key encryption algorithm. Finally, the decryption manager enables the decryption of encrypted datasets of a data provider once downloaded locally, provided that a valid contract exists, by the data consumer. It interacts with the encryption manager through SSL-enabled connections for the reception of the symmetric key. In the core platform tier, we have the master controller that compiles a set of instructions for the execution of the specific jobs and tasks as provided by the components of the core platform for local execution either on the on-premise worker or the secure space worker. The data handler acts as the data gateway of the platform, undertaking the tasks that are related to making the data available from and to the platform across all the tiers, as well as across all the different platform components. The data license and agreement manager is responsible for handling all processes related to data licenses and IPR attributes, as well as the drafting, signing, and enforcement of smart data contracts that correspond to data sharing agreement between the platform users. The policy manager provides the authorization engine that is based on the ABAC model and incorporates the required authorization XML-based policies. It prevents unauthorized access of any type of resource of the platform, such as data, services, tools, or any kind of system resources, as well as other relevant objects. The storage and indexing provides the storage and index maintenance of large, complex, and unrelated datasets within the platform, as well as the flexible and high-performance indexing of the stored datasets. The Query Explorer offers dataset exploration and scalability functionalities of the platform, is the main facilitator of in the marketplace functionalities and the main interaction point for the user's perspective in the marketplace. The Recommender provides enhanced recommendation functionalities that enable dataset exploration and discoverability. It is responsible for recommending and suggesting the users additional data based on their searches. The keeper administrator facilitates the exchange of the decryption keys between the data consumer and data provider in order to enable the end-to-end data encryption and, of course, the secure sharing of encrypted datasets. The resource orchestrator is responsible for the provision of the secure and private space with the deployment and monitoring of containerized services via Docker and Kubernetes. The secure storage is the storage of the sandbox that the data providers' datasets are stored in order to be used in data analysis and for storing the produced results of the data analysis. This is composed by Hive and Presto operating on top of HDFS. The analytics and visualization workbench enables the design and monitoring of data analytics workflows from the core platform that are executed within the context of the secure and private space. The BDTA application catalog is a repository of these applications that are created by the user that can be stored, retrieved, modified, and loaded in the analytics and visualization workbench by the users at any time. The data preparation manager offers a series of configurable data manipulation steps in order to prepare the datasets for the secure storage for consumption from the secure storage for consumption by the analytics and visualization workbench based on the user needs. Finally, the notification manager provides notifications to the users related to the availability of new datasets according to the configured preferences, any possible updates on the datasets that the users are entitled to use, as well as any updates on the execution status of the scheduled analytics jobs. And the usage analytics is a tool that collects, analyzes, and visualizes the usage of the various sources and assets of the platform in order to extract useful insights and statistics. In the third tier, the secure and private space, it is composed by a secure space worker that performs the local execution of the job as instructed by the core platform, utilizing the deployed services running on the secure and private space. The jobs scheduler and execution engine is in charge of initiating, executing the analytics jobs that are designed by the analytics and visualization workbench on the core platform, as well as managing the resources available to the execution cluster nodes in the context of the secure and private space. And the execution cluster is the private cluster computing framework instance that is deployed within the secure private space and it's managed by the jobs scheduler and execution engine. This is based on Apache Spark framework. The encryption manager on the secure and private space encrypts the results of the data analysis before they are securely transmitted and stored in the secure storage, following a symmetric encryption based on the EAI's 256 symmetric key encryption algorithm. Finally, the decryption manager enables the secure decryption of the encrypted datasets of the data provider on the data consumer side. It decrypts the selected datasets prior to the execution of data analytics workflow. Finally, and also decrypts the results of data analytics workflow prior to the execution of the visualization process. The evaluation of the Icarus platform is an ongoing process. As the implementation of the platform has recently been completed in terms of development, the evaluation process in terms of performance, efficiency, and security has just started. However, the concept, approach, and technical solution will be verified, validated, and evaluated through four core representative use cases of the overall aviation value chains that I will explain in details one by one. The extra aviation services in an integrated airport environment is the first use case that aims to enable capacity enhancement decisions to achieve a sustained increase in throughput performance and to increase capacity in all weather conditions. It involves the execution of descriptive and predictive analytics in the secure experimentation sandbox for capacity modeling, airport traffic forecasting, flight delay prediction, position and slot allocation and scheduling, and it aims to optimize airport airside capacity, improve airport airside infrastructure, and the runway operations capacity. The second use case is the route analysis for fuel consumption optimization and pollution awareness that aims to perform pollution data analysis and massive route network analysis and evaluation in order to produce more accurate analysis of pollution data and aircraft emissions, by modeling the pollution of data, the prediction of aircraft performance in relation to the environmental impact. Finally, it aims to analyze pollution data on the larger scale of a massive route network, including statistical evaluation of weather data, modeling of aircraft payload capacity scenarios, and prediction of aircraft performance in relation to the underlying route network. The third use case is the aviation-related disease spreading that aims to introduce non-incremental improvements in the existing metadata population model by integrating additional available data, aviation-related data like traveler's age, structure, gender, and income data. It will assess both qualitative and quantitative the modeling capabilities, and it aims to analyze the accuracy of the prediction in historical and current epidemic forecast. The final use case is the enhancement of passenger experience using Icarus data that aims to reduce the cabin food waste towards the increase of revenue by optimizing the loading weight of the duty-free and catering trays on board, while also at the same time reducing the cabin food waste. Also, it aims towards the prediction of profitable discounts and offers to increase in-flight sales by suggesting discounts and offers targeting this increase of in-flight sales. To conclude, the Icarus Big Data Platform is a big data-enabled platform that enables data preparation and data uploading, addressing the security and privacy constraints of the data providers. It provides an intuitive aviation data intelligence marketplace for data exploration, sharing, and brokerage in a secure and trusted manner. It enables the provision of a sophisticated environment that completely guarantees the safety and confidentiality of data, while also enabling the execution of analytic experiments in closed lab conditions. Our goal is to effectively and securely address the critical barriers for the adoption of big data in the aviation industry and to enable the execution of aviation-related big data scenarios for EU-based companies, organizations, and scientists. That's all. Thank you.
Hello everyone, my name is Shuaiyuan, come from Central China Normal University. I'm honored to have this chance to share our research. The title of our paper is Early Detecting the At-Risk Students in Online Courses based on their behavioral sequence. My report contains 5 parts. Let's begin our first part. Introduction. In the past decade, thousands of online learning systems have emerged, providing different online learning services for different kinds of learners. Compared with the traditional face-to-face teaching, online learning have many advantages. For example, it breaks the limitation of learning time and space, expands the skill of the learners. However, there are also some problems in online learning, one of which is that participation of learners is low. It leads many learners to fail in online courses. To solve this problem, many research suggests to using big data technology to identify at-risk learners timely, to provide learning intervention or support for them. From the previous literature review, nearly all the existing research used aggregate data when extracting the predicting indicators. Without consider the dynamic pattern of the prediction indicators. To integrate the dynamic pattern of learning behavior into predicting model and improve predicting actions, our paper proposes an online learning result predicting method based on long short-term memory neural network. The second part, related work. According to the basic process of learning result predicting, existing research have focused on 2 aspects: design, predicting indicators, and developed predicting model. In the aspect of predicting indicators, research have employed the impact of many indicators on the effect of learning result predicting from different perspectives. Recently, some research summarized 3 kinds of indicators used in learning result predicting: human and computer interaction indicators, human and human interaction indicators, and individual tendency indicators. The earlier result of online learner result predicting mainly used human and computer interaction indicators and human interaction indicators. But in recent years, more and more research began to introduce some advanced psychology characteristics into learning result prediction model to further improve its actions. So many research show it difficult to find a set of general predicting indicators, so we should select appropriate predicting indicator for special situations. The aspect of predicting model development, The predicting variable defined by most of the research is a binary classification variable or a continuous numerical variable. According to the different predicting variable defined, the research adopted different predicting algorithms to develop a predicting model. Traditional machine learning method and neural network are usually used. The traditional machine learning mainly include IOR, DT, NB, KNN, SVM, RF, and so on. The exciting prediction algorithms are the traditional class machine learning algorithms, and a few kinds of research have explored the effect of listed advanced machine learning algorithms on learning result predicting, such as deep learning neural network. The third part, in order to integrate the dynamic pattern of learner behavior into the learning result predicting model, our paper proposes a learning result predicting method based on LSTM. The framework of this method is shown in Figure 1, which includes two paths: predicting model development and learning result predicting. The basic process of predicting model development is as follows. The first step, aggregate each learner's score. The second step, select the appropriate predicting indicators. The third step, take 1 week as a period and generate a sequence dataset. The last step, train the LSTM-based predicting model. From the lecture review, we can see that research have explored many predicting indicators from many aspects. As the goal of this study is to explore whether the dynamic pattern of learning behavior can be made and improve the issue of learning result predicting. Our study only considered the learning behavior indicators. In addition, because the data used in study is from Open University's Learning Assess dataset, when selecting the learning behavior indicators, we can only choose from the learning behaviors recorded in the dataset. Although OULAD contains 20 different types of learning behavior, not all courses contain these 20 types of learning behavior. Because the course selected in this study only contains 9 types of learning behaviors, these 9 types of learning behaviors are selected as the predicting indicators. These 9 learning behavior indicators are seen in Table 1 for a detailed description. After selecting the predicting indicators, the value of each predicting indicators in a period can be calculated for training the predicting model. As mentioned above, most of the research obtained values of predicting indicators from the calculated data to train the predicting model. Different from this research, our study calculates the value of each production indicators in different time periods to generate the sequence state to train the LSTM model. They need to be transferred to generate the sequence state of each product indicators. The process of sequence data generation is shown in Figure 2. In order to use the dynamic characteristic of learning behavior to improve the assurance of learning result predicting, we adopt the LSTM network to development learning result predicting model. LST network is a special kind of RNN which can make full use of not only the useful information close to the current position, but also the useful information far away from the current position. Different from the structure of recurrent unit in simple RNN, the LSTM recurrent unit have a special structure with 3 gates, which are usually called the input gate, forget gate, and output gate. The long short-term memory network is shown in Figure 3. This is the current state of the neural network. This is the state of neural work last time. This is the output of neural network last time. This is the candidate state obtained by non-learning function. This is the input of the current time. This is the input gate of the recurrent unit. This is the forgotten gate of recurrent unit. This is the output gate of recurrent unit. Forgotten gate decides how much information of the state of last time decided to be forgotten. Input gate decides how much information about the candidate date at the current time needed to be saved. Output gate decides how much information of the current state needed to be passed to the output of the current time. To the forward propagation process of LSTM network, our study takes the sequence date of behavioral indicators from the first week to the nth week as the input of the LSTM network. It uses the back propagation algorithm and the gradient descent algorithm to train the LSTM network to predict learners' learning results and identify at-risk learners. We should train an LSTM model for every week. The fourth part, experiment and result. Our study selected the EAI course from OULAD. The course lasts 169 days, taking 7 days as a week, 38 weeks and 3 days, plus 4 days, a total of 39 weeks. The number of learners in experiment is 3,081. There are 9 behavioral operations. Each kind of behavior is shown in Figure 4. During the experiment, the train site and test site are assigned according to 16% of train side and 14% of text side. Behavioral data is processed in two ways: aggregate data and sequence data. Aggregate data. The course contains 3 weeks, with 5 weeks as the time node. The first 5 weeks, the first 10 weeks, the first 15 weeks, and so on. The non-behavior characters in the time node segment are aggregated for statistics, and the data processing result of each time node segment are non-clone data. Take 1 week as the unit. The aggregate date of 9 behavior were counted, then the first 5 weeks, the first 10 weeks, the first 15 weeks, and so on. The data processing result of each time node period were n tests, 9 clones. Sequence date not only influence the total amount of each behavior in a specified time period, but also can compare the number of behavioral changes in different time periods. This paper mainly solves 2 problems, which is the greater influence of on learning result prediction. Sequence data or aggregate data. Which model is the best model to predict the learning result of sequence data? To solve the above problem, the following 2 experiments are designed. The first experiment is comparison of prediction models on aggregate data and sequence data. According to the prediction model of learning result used in the related research, 8 classical machine learning algorithms were selected. Aggregate date and sequence date of the first 5 weeks, the first 10 weeks, the first 15 weeks, and so on. Value of various prediction models were compared. The parameters of models are set as follows. According to the experiment, the number of entries may be different when the input data changes weekly. Since the test site and the train site are assumed, the value of AUC predicted by each model may be different. Therefore, each model on the aggregate date and the sequence date in different weeks are experimented for 10 times, and the average value of predict AUC is taken as a final prediction result on aggregate date or sequence date in this period of the model. The second experiment is designed as prediction model of learning result based on the sequence date. The best prediction model of learning result selected from the last experiment are compared with RNN model and LST model on sequence date. RNN is mainly used for the prediction on sequence date. In this experiment, we use curious week. The RNN model is constructed in 3 layers. The input layer is a 3-dimensional vector: input site, time steps, cell size, input size, is the length of data in each time period, that is, the number of futures. In our research, input size is the 9 futures extracted in the earlier state. Time state is the number of weeks. Cell size is the number of neurons, which is set as 341. RNN has a greater advantage in processing sequence data. It can use the previous information to carry out corresponding operation on the current task. But if the location is far away, it can't be operated. LSTM is a special RNN model which can solve the problem of long dependence. In the experiment, LSTM is a 3-layer. The input layer of LSTM model is also a 3-dimensional vector. Input set, time steps, and cell size. The mean input size is the length of data in each time period, that the number of futures. Input size is the mean futures extracted in the earlier state. Time steps is the number of weeks. RNN and NN models. The AUC values of LSTM models is also the average value of 10 times prediction result on sequence data in each time period. Classic machine learning model LRNB, RF, KNN, SVM, CART, ID3, NN are used to predict the learning result on accurate date and sequence date. The prediction results are shown in Figure 5, where A represents aggregate date and S represents sequence date. The blue line represents the AUC of prediction model on aggregate date, and the orange line represents the AUC of the prediction model on sequence date. The experiment shows that the prediction effect on sequence date is better than that on aggregate date. The RF model and the CART model are better than other models. The experiment in the prevent section proves that the prediction results on sequence date are much better than those on aggregate date. RF model and CART model with the highest average AUC value in each time is selected as the representative of machine learning model and compared with RNN model and LST model. The results are shown in Figure 6. The blue lines represent the AUC of RF model. The red line represents the AUC of CART model. The blue line represents the AUC of RNN model. The last line represents the AUC of LSTM. The present shows that the CART model is the worst of the 4 models. The LSTM model has the best prediction effect of 4 models. Last point, conclusion and future work. Conclusion 1. 8-class machine learning methods are selected to predict the learning result in different time nodes based on aggregate date and sequence date. Sequence date is more effective for the prediction of learning result than aggregate date. RF model and CART model are the best model of the 8 prediction model on sequence date. Conclusion 2. RF model, CART model, RNN model, and LSTM model are used to prediction learning result on sequence date. LSTM is a model with the highest value of AUC and stable growth based on the sequence date. In our future work, we will mean the sequence of learning behavior types based on sequence date. We will improve the deep learning model of learning result prediction to predict the learning result earlier. This work is inspired by the following project thanks to my team members. That's all. Thank you.
Hello, everyone. My topic is does college students adapt to personal learning environment (PLE), a single group study. Introduction and the background. The biggest impacted of the COVID 19 on students is the transition from studying at school to online learning at home. Adapting to the home online learning environment is the key to ensuring the quality of learning. Many Chinese college students have built a personal learning environment with online learning platform, society software, cognitive tools, and home environment as key components. As an educational emergency, whether students can effectively construct and adapt to their personal learning environment and provide students with high-quality learning resource is a concern of Chinese society. Personal learning, as Simon said, personal learning environment is a combination of tools created under the concepts of openness, interoperability, and learning control. Studies from Chinese research have shown that living teaching in online learning at home is full of conditions. However, students' low efficiency has caused various doubts and complaints. So, how to enable students to better participate in online learning at home is a problem related to the long-term perspective of lifelong learning. Research on the adaptation status and basic characteristics of the personal learning environment of college students during the epidemic and discover the influencing effects that hinder their participation in online learning. It's an important problem for self-directed learning related work. In this paper, we talked about research on connection of personal learning environment, the model and frameworks of personal learning environment, and applied research on personal learning environment. Method. This research was conducted on the graduate from Shandong Youth University of Political Science from February to June 2020. It's a single group study. After confirming their participation in the research, 18 students reached 19 minutes training section in order to give students time to experience and reflect their online learning. The training is arranged in the fourth week after the start of the course. The evaluation conducted at the beginning of the course and the end of the course, interval of 4 months. Now, this is the baseline characteristics of the participants. This is the content of training. Inclusion 5 or 6 parts. One is introduction. Second is what is self-direct learning. The third is the impact of attention and habitual behavior on online learning. The fourth is methods of self-regulation. The fifth is attribution of learning outcomes. And the last one is review and design action plans. Instruments. The research tools for middle multitasking self-efficiency was the MMSG skill proposed by Professor Wu Junyu, which have 5 questions. The learning certification research tool used a skill developed by accuracy, which have 4 items. Analysis. According to the research designed by the UC Nazareth, in this study, one-dimensional intra-group analysis of variance corrected by Greenhouse and Jesser was used to analyze the scores of adaptability index. For example, MMSE, PAD, SRS, SAT, before and after the course. Now, this is the difference of the adaptabilities variables of students in PLE before and after training. Now, you can see nearly all the variables, adaptability variables is not significant. Here, yes. Okay. Discussing and conclusions. Learners had a moderate degree of attention deficit in their personal learning environment, which is manifest in 3 aspects. One is perceptive attention discontinuities, lingering thoughts, and society or social media notification. Under simple training or natural conditions, students have poor adaptabilities in their personal learning environment, and their behavior perception and behavior adjustment has been improved, but they have not yet reached expectations. The third conclusion is participation in online learning has significantly increased the application of learning self-regulation strategies, especially the application of behavior strategies. Now, in their work, we explored the adaptability and dynamic characteristics of college students online learning through a single group design. Although we have been trained once in the research cycle, it's about 4 months. It's about 19 minutes. The results are not ideal. We hope we expect students can adapt to their personal learning environment through some training, but the results not ideal. Continuous research on the adaptabilities and laws of lifelong learners' personal learning environment appeared to be very necessary. So, this is the limitations in this paper. On the one hand, the research cycle is short and the amount of collected data is not rich enough. This study lasted only 4 months, which has a certain impact on the systematic and in-depth insight into the dynamics of students' adaptation. On the other hand, this study only uses descriptive statistics and intergroup analysis of variance and doesn't reveal the relationship and comprehensive effects between the research variables. Acknowledgements. In this paper, I owe thanks to Professor Wu Jinyu of Taiwan National Jiaotong University for his guidance and help. In our work, I talked about some important topics with Professor Wu, and he provided his OLMMR skill to me, and this is very important to continue my research. Thank you to Professor Wu Jinyu. That's all. Thank you.
This presentation is about a multi-valued logic assessment of organizational performance via workforce social networking. It is organized in 4 main points: introduction, knowledge representation and reasoning, case study, conclusions, and future work. Social media have changed the conditions and rules of social networking where it comes from people intermingling with each other. Social networking is to be understood as a process that works on the principle of many-to-many. For example, any individual can create and share content. Beliefs, expectations, group knowledge, and general knowledge have therefore become central concepts in the development of social networking. This study aims to look at and explore the complex dynamics between social networking, logic programming, and the laws of thermodynamics. The assessment of organizational performance via workforce social networking was carried out based on a workable problem-solving method in terms of an evaluation of the entropic states. The analysis and development of the proposed system is based on a series of logical formalisms for knowledge representation and reasoning that are grounded on logic programming, complemented with an artificial neural network approach to computing. In order to describe the fundamentals of the proposed approach, the first and the second laws of thermodynamics must be considered. The first law of thermodynamics states that the total energy of an isolated system is conserved over time, or in other words, energy can be converted but not generated or destroyed. The second law of thermodynamics deals with entropy, a property that quantifies the state of order of a system and its development, being a measure of perturbation in a closed system. The energy that determines the orderly state of a system and its evolution is given here in terms of exergy, vagueness, and energy. Exergy is the part of the energy that can be arbitrarily used, corresponding to the dark-colored areas in the figure. Vagueness corresponds to the energy values that may or may not have been consumed, being given by the gray-colored areas, and energy stands for an energetic potential that was not yet consumed, being therefore available, corresponding to the dashed areas. A questionnaire to assess the social networking was created and used for a cohort of 30 workers ranging from 20 to 60 years of age, with 60% women and 40% men. The questionnaire was divided into 2 sections, the first containing general questions, for example, age, gender, and academic and organizational qualifications. The second part included statements on entertainment, constraints, academic and organizational and socialization related items. In order to collect information about workforce social networking, the participants were asked to tick the option that best reflects his/her opinion regarding each statement. The scale used was made upon the terms strongly agree, agree, disagree, strongly disagree, disagree, agree, and strongly agree. The statements under consideration were divided into 4 groups: entertainment, constraints, academic and organizational, and socialization. The entertainment questionnaire encompasses the statements: I use social networking sites for sharing pictures. I use social networking sites to look at funny sharing. I use social networking sites for watching movies, and I use social networking sites to get relief from academic and organizational stress. The constraints questionnaire includes the statements: I face difficulty in finding exact information for academic via social networking sites. compulsive usage of social networking sites is a problematic issue. I usually postpone my academic task for spending more time on the social networking sites, and while using social networking sites, it is difficult for me to concentrate on my studies. The academic and organizational questionnaire comprises the statements, I use social networking sites to solve my academic, research, and organizational problems. I use social networking sites for online academic and organizational group discussion. I communicate with my friends via social networking sites for preparation of group work. I use social networking sites for collaborative learning and organizational practices. I use social networking sites to learn about my curricular aspect, and I use social networking sites to seek help from my peers and colleagues. Finally, the socialization questionnaire contains the statements, I use social networking sites to become more sociable. I use social networking sites to create my social identity. I prefer using social networking sites to attending social gathering, and I use social networking sites for strengthening interpersonal relationships. In order to quantify the qualitative information collected and make the process intelligible, complete calculation details for socialization questionnaire are provided. The following table presents the results regarding an applicant's answer to this questionnaire. The answer to S1 was strongly agree and agree. The applicant indicates that he strongly agrees with statement S1 but does not reject the possibility that the answer can be agree in certain situations. This answer shows an entropy increasing trend and the adaptation level tends to decrease. The answer to S2, disagree and agree, shows a trend in the development of the system with the decrease in entropy and the adaptation level tends to increase. For S3, the answer was agree, a fact that speaks for itself. For S4, no options were marked, which indicates a vague situation. In this case, the value of the energy consumed is unknown. The figure below describes such responses in terms of the different forms of energy, exergy, vagueness, and energy. Exergy corresponds to the dark-colored area, vagueness corresponds to the gray-colored area, and energy corresponds to the dashed area. Thus, it was possible to compute the values of exergy, vagueness, and energy for the best-case scenario and for the worst-case scenario. Proceeding in a similar way for the remaining groups, it is possible to compute the respective values of exergy, vagueness, and energy for both scenarios. Furthermore, it is possible to evaluate the performance of each predicate and its quality of information. The evaluation of predicate performance and its quality of information for the different statement groups are as follows. Applying the procedure described above for each participant, it is possible to obtain the knowledge base that supports the training of an artificial neural network, the social networking assessment, plus a measure of its sustainability. The extent of predicates, entertainment, constraints, academic and organizational, and socialization are used as inputs for the ANN. The outputs are the social networking assessment plus a measure of its sustainability. Finally, the main conclusions and future work can be summed up. This study presents a data collection and computational model that intends to assess workforce social networking based on mathematical logic and the laws of thermodynamics. This approach focuses on processing information collected through questionnaires to prevent undesirable events. In future work and pondering how the various factors can influence the social networking, new groups of statements will be taken into account. Thank you for your attention.
Good afternoon, everyone. I'm Mingli Shan. I'm from Shandong University of Political Science, China. My article topic is statistical research on macroeconomic big data use Bayesian store volatility model. That's the first abstract. The alternative variation of varies in stochastic volatility models provides a big data model solution that is more suitable for the fluctuation process in macroeconomic for describing our observable blockchain features. The estimation method based on Monte Carlo simulation shows unique advantages in deal with high dimensional integration problems. The statistic research on macroeconomic big data based on Bayesian store volatility model built on the Macroeconomic Monte Carlo estimation. The theoretical values of the statistics can be defined exactly, which is one of the drawbacks of traditional statistics. Most importantly, the model proves effective analysis tool for the expected variable generation behavior caused by macroeconomic big data statistics. Then the keywords is Bayesian stock volatility models and economic big data statistics and Monte Carlo simulation algorithms. Then the articles is one theoretical basis and research significance. 1.1 related concepts. The first, the Bayesian algorithm, the basic formula is this, like so that the stochastic volatility model is the second. The third, the Monte Carlo method is used to construct a sample. The last one, the nonlinear structure of macroeconomics. Then the 1.2 research significance. The first theoretical significance. The second is practical significance. 2. Purpose and content. 2.1 is main research purpose. This research aims to focus on a typical time varying volatility model. In the entire development trajectory of the big data time varying volatility model. Research in this area mainly focus on the classical statistical model theory. It is difficult to determine the level of accurate critical values. And the 2.2 is research context and technical route. The first is under the classical statistical modern theory system. Research of improved algorithms and applications of regression are conditional on heterostatic models and their respective extended model in the area of macroeconomics. The second is for the application of the Bayesian model in the non-linear structure of the macroeconomics. We focus on big data algorithms. The third, the MCMC sampling algorithms estimation of the SV model will generate potential state variables of the simulated data. And then the 2.3, the main content of the research. There are three formulas so that like this. This is the first one. This way, the information contained in the data set can respond to the appropriate conditions, where weighting coefficients are assigned to the MCMC Fourier distribution, as such as this, the first. The second, the Fourier distribution of the mean conditions on the convergence matrix is an independent multivariate normal distribution. The last one is the prime of the exact matrix is given by the MCMC distribution, including the focus on several topics. 1 point, the research group proposed a variety of standard MCMC sampling algorithms for SV model based on an analysis of the research phase and the related background of time varying wave models at home and abroad, as well as Monte Carlo simulation methods. 2 points, based on the background of macroeconomic applications, the existing SV model has been expanded and improved. 3 points, in online data analysis, where the model parameters are unknown, the parameter learning method based on sequential Monte Carlo is further discussed. 4 point for the variable structure of an SV model. The model contains some extreme cases that are of particular importance to risk management. 3. Analysis. 3.1. The Bayesian Stochastic volatility model is used to identify and analyze the SMC of major macroeconomic big data indicators. And the 3.2. In the process of time series modeling, the main purpose of the research is to extract the statistical characteristics rules from the observation data containing noise, with the final goal to make effective statistical inferences for MC identification. 3.3. In addition to resolving the cumbersome calculation issue, the state space form of this big data model also provides a more effective way to simplify the maximum likelihood estimation and deal with missing values. 3.4. In nonlinear and no Gaussian state space big data models, simulation-based filtering methods provide a more general solution for the symptom identification problem. 4. Conclusion. 4.1. In the field of macroeconomic risk research, the modeling and estimation of big data time series are undoubtedly of great significance. 4.2. With the continuous development of the economy and the macroeconomic system, Monte Carlo simulation can help solve the complex numerical calculation problems in the estimation of big data models, and the behavior of expected variable generation will also change accordingly. 4.3. The time varying fluctuation mode based on Monte Carlo simulation also provides an effective research tool for solving the above stated problems. 4.4. The Monte Carlo simulation method provides a set of effective estimates for various models. And that's all. Thank you.
Hello everyone, my name is Muhannad Sarhan. I'm a PhD student at the University of Queensland in Australia, and today I'll be presenting our research paper, NetFlow Datasets for Machine Learning-Based Network Intrusion Detection Systems. I'll start by giving a little bit of introduction on network intrusion detection systems and their different types, and then I will explain the importance of data when it comes to the machine learning-based ones, and what are the current limitations of existing data sets that are used for training and evaluation of these machine learning models, and how this paper overcomes these limitations by generating 5 new NetFlow datasets. And as a use case scenario, we implement a machine learning classifier and conduct both binary and multi-class classification. So I think it's safe to say that we've all here heard about some major cyber attacks that have targeted organizations and networks over the past years. An example would be the incident that took place in July last year over an American bank called Capital One. It has exposed 106 million people-sensitive data, such as social security numbers, addresses, and contact details. The graph here shows that there is an increased rate of data breaches over the last 5 years, and that's only expected to keep increasing, as well as the risks associated with these attacks. So therefore, businesses and governments are looking for new ways to protect their digital assets and networks. There are a few layers of security implemented over a network. It could be an endpoint such as computers or servers, or at a firewall level. But today's focus will be on Network Intrusion Detection System, or NIDS. They're implemented in a network to detect network attacks, which is done by analyzing and scanning the incoming network traffic. But as we do face new kinds of attacks due to the growth and advancements of networks, the current NIDS technologies have been proven unreliable, especially against new attack strategies, which is also known as zero-day attacks. And that's why we need to design new approaches to enhance the detection performance of these systems. There are 2 main types of NIDS, signature-based and anomaly-based. The main difference between them is the concept behind their detection approach. The signature-based aims to match and compare incoming traffic signatures to a predefined list of recognized attacks. And that usually gives a high detection rate for known attacks, but it fails to detect zero-day or unknown attacks as their signatures have not been identified yet. So overall, it has a medium detection rate. The anomaly-based, it learns the behavior or the patterns of traffic, and then it compares the incoming traffic to that learned pattern. So they do achieve a high detection rate on both known and unknown attacks, as they focus on matching patterns and behaviors rather than signatures. On the other hand, it does suffer from a high false alarm rate, as any unique or unmalicious traffic that deviates from the secure behavior could be reported as an anomaly. There are 3 types of anomaly-based NIDS: the traditional, which is statistical and knowledge-based types, and also the machine learning-based, which started to gain the focus over the past few years, mainly due to the availability of data and computation power. So today's research is about machine learning-based NIDS, and to be more specific, we'll be conducting supervised classification experiments. As any other domain, when machine learning is applied, data is the key. In this case, as every network attack will have an identifying pattern, also known as the set of events, which are obtained from features that are transmitted through network traffic. Now, these patterns are learned and evaluated using network traffic datasets, or NIDS datasets. So these datasets are very important to build an ML-based NIDS model. And also due to the evolution of networks, these data sets will need to reflect modern behavior. In other words, data sets that are collected 10 years ago would have limited significance, as it would represent network traffic that looks very different than today's. There are two main types of data sets. Real data sets are realistic network traffic, which are collected from real-world production networks. But they're challenging to obtain for many reasons, including security and privacy concerns, as they can expose network traffic activities as well as organizational assets. But also due to the fact that production networks do not generate labeled flows, which is necessary when following a supervised classification approach. So therefore, researchers and academics have come up with synthetic datasets, which are created by virtual testbeds, such as the diagram on the right-hand side. They are made publicly available as they do not expose any real network usage. The authors are then able to conduct various attack scenarios, but also generate some normal benign traffic. These flows are then captured and then would be easily labeled as an attack or a benign class. The attack flows can be further labeled as the attack category. So this paper aims to convert different data sets to the same format and feature sets, which will allow comparison of NIDS classifiers across different data sets. For those of you who are wondering, that's how a dataset looks like. That's an actual subset of a very common dataset used in the field called UNSW NB15. So it's in a tabular form where the first row represents the features and each following row represents a data flow. So here we have features as separate columns, which also include two label features, a binary class where 1 represents an attack and 0 represents a benign flow, and a multi-class representing the attack type. Now it's very important to note and to say that each data set has its own unique set of features, which makes them very different in terms of the information represented. So the current data sets issues. There is no benchmarked or standard set of features to be used in the generated NIDS datasets. So therefore, datasets authors have utilized their own domain knowledge to extract pre-identified network features, which they thought would aid in the classification process. But as a result, each dataset out there has its own unique and completely different feature set. And that has caused two main issues. The first one would be the dimensional overload, as we do collect and store all of them, some of which are irrelevant, would require a higher computation and storage facilities. The second main issue is that each machine learning model published by researchers have been trained and evaluated on multiple datasets, which is important for a reliable evaluation. However, as each dataset has its own different feature set, the evaluation is unreliable, simply as the researchers would be unable to evaluate the model's generalization across network settings or attack scenarios using the same feature set. That limited ability to efficiently evaluate a machine learning-based NIDS has led to a gap between the extensive academic research conducted and the actual practical deployments of these systems. Data sets, known as the UNSW NB15, BOT IUT, TON IUT, CIC CSC IDS 2018. They're all released within the last 5 years, so they do represent modern network behavior. They also all suffer from an extreme class imbalance, meaning they've got a majority of a class over the other. So UNSW NB15 and the CIS contain a large number of benign traffic to attack traffic, where the BOT IUT and the TON IUT would have a much larger number of attacks compared to the benign traffic. They've all got almost the same number of features except for the CIC dataset containing a much larger number of features. So that's a Venn diagram displaying the list of the shared and exclusive features of the four NIDS datasets. So as we can see, they only share 3 features between all of them, and only 1 to 5 between 2 of them. So this paper generates the NetFlow datasets as a proposed solution to the different feature sets issue. NetFlow is a very practical format of collecting and storing network traffic. It has been originally developed by Cisco, but it's being used in the industry-wide nowadays. It's used for collecting and monitoring network traffic and analyzing for security events or auditing purposes. It's highly practical, as most network devices such as routers and switches would have a built-in option of generating a NetFlow-based records. NetFlow evolved over the years. However, the most common version is version 9, as it's bidirectional and it contains a variety of features compared to the other versions. NetFlow brings 2 advantages in our case. The level of complexity and resources required to collect and extract these features are much lower compared to the original set of features. And we can bring all these data sets to a common feature set, so therefore the proposed machine learning models can be evaluated using the same set of features across various datasets attack types. So we've utilized the publicly available PCAPs or the packet captures of the utilized datasets, and we've used a tool called nprobe by ntop to extract certain NetFlow features out of the packet captures. And then for the labeling process, we've obtained the flow identifiers such as source IP, destination IP, and source port and destination port, and protocol, and comparing it to the ground truth or the attack events published by the original datasets. And if these records or these flows were found, we would obtain its attack category and label it accordingly. Otherwise, it would be labeled as a benign or unmalicious data record. So our generated datasets consist of 12 NetFlow features that are mentioned and described in this table. And in addition, there are two label features, the binary and the multi-class, to be used for the binary and the multi-classifications challenges. So this table compares the newly generating datasets to their respective original dataset. So we can all see that the newly generated datasets would have the same number of features and the same feature types. They're also less in size compared to the original ones, as NetFlow aggregates multiple records or multiple flows into a single record. However, they still inherit the class imbalance issue from the parent dataset. We've also generated a new dataset known as NFUQ-NIDS, which is basically the 4 datasets merged together into a single universal dataset. And that's one of the other benefits of the newly generated datasets. As they all share the same features, they can be merged together, creating a more comprehensive dataset consisting of a larger variety of attack types and different network environments. And to evaluate our datasets, just as a use case, as it's displaying the benefits for the first time, we can evaluate machine learning classifier across common features across data sets. We've chosen the extra trees classifier, which belongs to the trees family, and have proven great results in NIDS domain. We conduct both the binary and multi-class classification, and we compare the results to the original data sets. We collect performance evaluation metrics, such as the area under the curve, AUC, which plots the detection rate on the y-axis and the false alarm rate on the x-axis. The higher the score towards 1 would be an optimal NIDS. We also collect the F1 score, accuracy, detection rate, and false alarm rate. Classification results. We determined that the newly generated datasets achieved a very similar results to their respective parent datasets. Keeping in mind they have a much lower number of features. The prediction time, which is the time required to predict a single data record, also decreased due to the less number of features analyzed. The main universal dataset achieves an AUC of 0.9669 and a detection rate of 95.66 and a false alarm rate of 2.27%, which is a reliable performance. The NF-TON-IT achieved a higher performance compared to its parent dataset. It achieved a 0.9965 AUC in AUC. The bot IUT, however, achieved a lower performance compared to its parent dataset that achieved 100% detection rate. The NF-UNSW NP15 and NF-CSC achieved a very similar performance compared to their parent dataset. Moving on to the multi-classification results, the UNSW again achieved a very similar result of a weighted F1 score of 0.98. Again, the bot IT achieved a much lower performance compared to its parent dataset when it comes to multi-classification. The TON IT achieved a much higher results compared to its NetFlow dataset of 0.87 weighted F1 score compared to 0.60. The CSC-CIC IDS 2018 also achieved a higher performance of 0.94 weighted F1 score compared to 0.80 of its NetFlow dataset. The Universal Merged Dataset, NFUQNIDS, achieved a weighted detection rate of 70.81 and 0.79 F1 score, which leads to the conclusion and future work. The paper provided the research community with 5 NetFlow datasets using 4 existing benchmark datasets. As they all have the same feature set, they would allow the comparison of ML-based NIDS algorithms across different datasets. As we noticed, the multi-class classification results are unreliable, so the future work would include expanding the current NetFlow datasets with additional features, as well as identifying the key features required from the original datasets to detect certain attack types. So the datasets have been published and publicly available online on the UQ webpage, available on the below of the slides. Thank you, everyone. I hope you enjoyed it.
My name is Panagiotis Kasnesis, and I work as a postdoc researcher in the University of West Attica, and especially the Concept Lab. Today, I'm going to present you a paper entitled Introducing and Benchmarking a One-Shot Learning Gesture Recognition Dataset. Wearable gesture recognition exploiting deep learning techniques has been widely and successfully applied over the last 5 years to enable human-computer interaction in several domains, such as smart home environments, smart factory, physical security, and many others. However, the collected datasets are built in an old-fashioned way, mostly comprised of few subjects that perform many times few different gestures or activities. As a result, when it comes to few-shot learning tasks, existing large datasets are arbitrarily downsampled and split into train and test sets, leading to unfair comparison between the machine learning algorithms. Consequently, we built a one-shot learning gesture recognition dataset called Sensed, which is, to the best of our knowledge, the first wearable-based gesture recognition dataset particularly built for one-shot learning. And when we say one-shot learning, we mean that the classification algorithm must correctly make predictions given only a single example of each new class in the test set. In order to evaluate the dataset, we developed 3 deep learning approaches for one-shot learning with promising results. Finally, the collected dataset is made publicly available to be used as a benchmark for one-shot learning wearable gesture recognition. Now, as you can see in the table presented, the dataset is designed to contain a total of 46 characters. The first 26 are all the English capital letters meaning from A to Z. The next 10 characters include all the 10 digits ranging from 0 to 9. The last 10 characters include most commonly used characters and math symbols such as the dollar and the percentage. The English capital letters were used as the training set, the numbers were used for creating the validation set, and the special characters were used as the test set. In total, 35 subjects participated in the creation of the dataset and performed the gesture only once. However, not all the subjects performed all the characters. 25 of them wrote the English letters, 5 subjects wrote the digits, and 5 subjects wrote the remaining special characters. We selected the Fossil Generation 5 smartwatch to produce the motion data and built 2 native Android applications, one for the mobile and one for the smartwatch. The smartwatch application was used to capture and save the raw data from the sensors, while the smartphone application was used for labeling them. After wearing the smartwatch, the subject would select the character to execute from a list in the main screen of the smartphone application. Then the device would send the symbol to the smartwatch and it would start capturing the triaxial accelerometer and gyroscope data for 3 seconds duration, producing 150 values, as the sample rate was equal to 50 Hz. A vibration of the watch would signal the beginning and the ending of the capture. Afterwards, the data would be saved in CSV format. As you can see in the right figure, in order to create a homogeneous dataset, subjects were provided with instructions on how to draw each character. The instructions included the pattern they had to follow for each character, along with the starting and ending point for the symbol, the lines of curve they had to draw, and the order they had to follow. The starting point is shown as a blank circle and the ending point as a solid filled circle. Additionally, dashed lines show where the subject should have to lift the hand and not draw anything. Despite the pattern limitation, subjects were free to choose the hand they could use, left or right, to choose whether they would be sitting or standing, and to select the writing surface. That could be a paper, a whiteboard, or simply draw the character in the air. Now, when it comes to the definition of the problem, one-shot learning datasets are typically consisted of 3 sets: the training set, the validation set, and the test set. Each one of them contains disjoint label spaces meaning different gestures. The main objective of the few-shot learning setting is to extract transferable embeddings or features from the observed gestures, including in the training set. One-shot learning is a subclass of few-shot learning setting where the classification is done under the restriction that only a single example of each possible class is observed before making a prediction about the test sample. Moreover, since sets contain 10 unique classes in the validation and test sets, the one-shot problem is defined as 10-way. As you can see, having a sequence N9 drawn by user I, the algorithm would specify its closest neighbors having as 10 digits to be compared with drawn by user J. So we followed 3 one-shot learning approaches. The first one is a vanilla embedding extraction, which is commonly used based on the transfer learning concept. In this approach, the deep learning model is firstly trained on a source domain, which is in our case the English capital letters. After training, the weights are frozen and applied to the target domain. Now, the validation and test signals go through the trained network, and the tensors produced by the last convolutional layers are stored. In the 10-way learning task, given a set of an anchor signal and 10 candidate signals, we select the embedding representing class C that has the minimum norm distance. The second approach was a Siamese network. It is an end-to-end learning approach for extracting embeddings where the deep neural network is replicated twice, meaning that the network shares the same filters for its input gesture sample. Just like the previous approach, the produced embeddings are compared using the Euclidean distance to directly predict whether the two input samples, the anchor and the candidate, belong to the same gesture class. However, this approach differs from the previous one because it does not aim at finding the nearest neighbor directly, but fits the produced absolute difference to a fully connected layer, followed by a sigmoid activation function. As a result, the output is mapped into a single logistic unit where different gesture signals should produce a value equal to 0 and the same gestures equal to 1. To this end, a binary cross-entropy function is used as a terminal step to define the loss function. The last approach is that of a matching network. It is similar to the Siamese network, but as you can see, it applies a different similarity metric which is close to a cosine similarity. Moreover, the produced similarity scores of the candidate similar signals are concatenated in this case, and the network uses a softmax and a categorical cross-entropy loss to define the output, which is also depicted in the figure at the right. The data sampling process was done as follows. In the case of the training set, the anchor gesture executed by a subject SI was compared with 10 randomly chosen gestures executed by a subject SJ. We selected to make 2000 10-way comparison for each English character, leading to 52 training samples. The same approach was followed in the cases of the validation and test sets. However, in these cases, all possible 10-way combinations were taken into consideration, yielding 200 samples for each set. These sets are stored and published to be used for future algorithm benchmarking. The signals were afterwards normalized and were given as input to two selected deep learning architectures that we have selected to be utilized by the 3 chosen one-shot learning approaches. The first network is a late sensor fusion convenet, and the second is a convolutional LSTM, meaning that 1 or 2 LSTM layers are applied after several convolutional layers. During training, we selected each model's best hyperparameters based on the validation accuracy, while the model that had the lowest loss on validation set was stored to be applied later to the test set. The table shown presents the results obtained by each one-shot learning approach and the deep learning architectures it was applied to. As you can see, the highest accuracy for both validation and test sets was acquired by the matching network that was used on top of a late deep convolutional neural network architecture, reaching 82% and 76.5% accuracy for the validation and the test sets, respectively. This figure that is presented here illustrates the confusion matrices of the CNN MatchNet algorithm for the validation and the test sets. It should be noted that the algorithm is classified many instances of class 6 to class 9. Apart from the fact that number 9 is a reversed number 6, this occurred because the users were free to execute the gesture using hand posture and writing surface of their choice. Consequently, the trained MatchNet covenant algorithm seems to be a non-orientation free algorithm and does not discriminate between the starting and the ending point of a gesture. In the test sets confusion matrices, some misclassification patterns can be observed also. In particular, the algorithm confused a few instances of equal symbol with that of plus symbol and vice versa, since they are consisted of two straight lines. It also confused instances of the star symbol and the hashtag, since they both consist of 6 straight lines. In addition to this, the dollar symbol was misclassified 3 times as euro, and the model struggled to recognize percentage symbol class. All of the aforementioned misclassification can also be seen in the two-dimensional TSNE embeddings representation on the right. Finally, despite the performance of the algorithms not being spectacular, especially if compared to those of Omniglot, which is a widely used dataset in computer vision, the produced results are promising. Even more so because Sensed is a more challenging dataset. 100 characters presented as images are time, rotation, surface, hand, and more importantly, subject independent. Thus, the trained algorithms are expected to generalize more successfully on unseen characters. On the contrary, in the case of wearable-based gesture analysis, the deep learning models have to generalize against all the aforementioned dependencies. To summarize, in this paper, we presented a publicly available wearable-based gesture recognition dataset called Sensed, designed and built specifically to meet the needs of the one-shot learning setting. It is considered to be a fairly small dataset for deep learning algorithms to be trained on, since it contains only one instance of each gesture performed by each subject, while the gestures contained in the training, validation, and test sets are disjoint with each other and are performed by different users. In our belief, the current dataset will assist researchers to test the generalizability of their algorithms on unseen gestures and serve as a benchmark for one-shot learning. Moreover, we have evaluated 3 one-shot learning techniques. The matching network architecture, built on top of a deep CNN, produced the best results, equal to 82% and 76.5% accuracy on the validation and test set respectively. Such recognition scores are considered to be promising, and one-shot wearable gesture recognition could be used to explore dynamic gesture-based user interactions with smart devices, as they might enable users to add moves of their own choice to smartwatches. Future steps include the exploration of more generalizable algorithms for domain adaptation, while the use of data augmentation techniques based on conditional generative adversarial networks could also be investigated. Before closing, I would like to point out that this research is co-funded by Greece and the European Union through the operational program Human Resources Development, Education and Lifelong Learning 2014-2020 in the context of the project on applying deep learning techniques to insufficient labeled session data for gesture recognition. Thank you all for listening.
Hello everyone, my name is Huang. My paper title is Research on the Sharing and Application of TCM Digital Resources. I will present my paper from the four aspects. The first aspect is introduction. Under the background of educational informatization, students' learning needs and learning styles have changed significantly, and the advantages of digital learning resources are fully reflected in the learning process. This new learning mode, based on advanced educational technology, can effectively promote the reform of teaching content presentation mode, teachers' teaching mode, and the students' learning mode, which not only puts forward higher requirements for teachers' personal quality, but also put forward new challenges to learning resources. In October 2015, the Chinese Medicine Industry Education Cloud Platform was officially launched. The digitalization process of Chinese medicine industry education officially began. Experts and scholars are actively exploring the construction of digital resources, and the TCM ancient books resources have been effectively developed. Although China has always attached great importance to the construction of high-quality teaching resources, due to the nagging development of education and the complexity of educational environment, the construction and application of high-quality teaching resources are still not optimistic. In particular, systematic research and development of digital learning resources related to traditional Chinese medicine is less. And they are still in the stage of learning and absorbing achievements. How to construct high-quality digital teaching resources, network platforms, and high-quality digital education resources in the information technology environment is a problem to be further studied. In the construction and application of digital resources, resource construction is the foundation and the guarantee. Resource application is the ultimate goal, and the resource construction should serve resource application, which in turn promotes resource construction. As an indispensable element in the process of digitalization of education, the construction and application of digitalization resources are paid more and more attention. Digitalization of TCM can be realized to improve resource utilization and provide services for TCM teaching, scientific research, and clinical application. In order to better meet the learning and teaching needs of students majoring in traditional Chinese medicine, it is necessary to build high-quality digital educational resources for traditional Chinese medicine, constantly promote the co-construction and sharing of digital resource network platform, and gradually realize the network and the digitalization of teaching and learning. The second aspect is analysis on the current situation of TCM digital resources. The analysis of the current situation of digital resources of traditional Chinese medicine is mainly carried out from two aspects. First, analysis the development and the changes of literature research in recent years from literatures related to digital learning resources of traditional Chinese medicine. And the second, analysis the digital resources of TCM in each network resource platform. The first is literature research status. The database selected for this study are 10th EAI one-bound data and Changqin WebP database. The selection of paper follows the following criteria. Papers should be published and be income to the academic paper database. Paper retrieval peer articles should be limited to education, medical science, and technology journals. Papers should be published between January 2009 and August 2020. When paper retrieval is carried out, subject is the limiting constraints. The results retrieved from each database are shown in the picture. Among the retrieved literatures, the literature with low relevance, such as advertisements, conferences, contribution invited, and news, as well as repeated literatures, were eliminated by manual screens. And finally, 295 literatures related to digital resources of traditional Chinese medicine were selected. Through the preliminary analysis of the literature content, the area of rapid development of digital network, the development trend of TCM universities is to strengthen the construction of digital resources while maintaining the characteristic of TCM specialty. In addition, through the network resource platform, realizing the resource sharing and application can accelerate the construction of digital resources and create a digital resources construction road with the characteristics of traditional Chinese medicine. There are 23 traditional Chinese medicine universities in China, and each university had built a website of excellent courses. The construction of excellent courses in each university are shown in the table first. Some universities cannot open the network of excellent courses normally, or we cannot obtain the data of excellent courses through other ways, so it is marked in table. Influenced by foreign open courses and drawing lessons from the essence of online open course teaching mode, the National Excellent Course Construction Project came to an end. In 2011, the Ministry of Education launched the second round of undergraduate teaching project, National Excellent Open Course Construction, including excellent video open courses and excellent resource sharing course. In this study, statistics on TCM-related resources in open resource platforms were conducted, and the results are shown in the table second. As can be seen from table first, a small number of excellent courses are not updated in time, or the course resources website cannot be opened, or there is no open course resources. All these are detrimental to the construction, sharing, and application of digital resources in TCM universities. As can be seen from table second, among the open resource platforms, the number of TCM-related open and the shared resources is not large, and the construction is insufficient. Students can use the resources in various open resource platforms for online learning at any time and anywhere, free from time and space restriction, and make full use of fragmented time for learning. Therefore, TCM universities should actively build excellent open and shared courses, give full play to the advantages of high-quality teaching resources, and improve the utilization rate of excellent teaching resources. The third aspect is application of traditional Chinese medicine digital learning resources. To investigate the application of digital resources of students' use of digital resources in the learning process, this study conducted a questionnaire survey for teachers and students majoring in acupuncture and Macroeconomic from a University of Traditional Chinese Medicine. We designed 2 questionnaires. One is about teachers' use of information technology in teaching. The other is about the application of digital teaching resources. The respondents are divided in 2 categories. One is teachers from College of Acupuncture and Orthopedics in University of Chinese Medicine, and the other is students from the class of Acupuncture and the Message of 2080 in the same university. A total of 10 questionnaires were distributed to teachers from colleges of acupuncture and orthopedics in the University of Traditional Chinese Medicine. 10 questionnaires were conducted in this questionnaire survey, and the recovery rate was 100%. Among them, there were 10 valid questionnaires, and the questionnaire effectiveness was 100%. The results show that it is feasible for teachers to use digital quality teaching resources in teaching. A total of 16 questionnaires were distributed to undergraduates from the class of Acupuncture and Message in a University of Traditional Chinese Medicine. A total of 16 questionnaires were conducted, and the questionnaire recovery rate was 100. Among them, there were 16 valid questionnaires, and the questionnaire effectiveness was 100%. The results show that students were more inclined to use video resources, text resources, media materials, and courseware cases when using digital resources. Through the rational and effective application of digital resources, students will take the initiative to accept the showing and show great interest in learning and change from passive learning to active learning. Acupuncture and Macroeconomic, the traditional Chinese medical means, combines theory with practice, has its special nature and charm. Usually, the knowledge of acupuncture and Macroeconomic of TCM is taught through traditional Chinese method. In order to truly optimize the application effect of digital resources and improve the quality of digital teaching and learning, corresponding countermeasures should be taken. There are 2 countermeasures. One is application of digital resources in different types of courses. The other is application of digital resources in different types of teaching content. Through the research on the current situation of traditional Chinese medicine digital teaching resources, the process of digital teaching is understood, and the necessity of digital education in the information age and the importance of digital resources construction are understood more clearly. Taking acupuncture and Max Bastian for example, this study suggests that the use of digital resources in classroom teaching should be focused, concise, and clear, and as much as possible to add some students easy to accept and understand the way of resource expression to highlight the intuitive teaching content, stimulate students' interest in learning, promote student understanding of teaching content, student positive thinking. The construction, sharing, and the application of TCM digital resources is a complex problem, and there are still some imperfections in this study which need to be further studied. The first one is giving full play to the initiative and creative of network groups and introduce public wisdom into the construction and sharing of traditional Chinese medicine digital resources. The second, in terms of the application of digital teaching resources, this study only proposed some suggestions on the application of digital teaching resources in acupuncture and Max Bastian, and the application strategies and effects need to be further studied. That's all. Thank you.
Dear ladies and gentlemen, due to the COVID-19, we changed the time of our conference for several times. There is an old saying in China, the best is always in the last. Today, we finally met this special forum. I believe that during today, all of us have obtained a fruitful discussion. In this BDTA 2020, we have learned a lot from the keynote session delivered by the amazing keynote speaker Huang, Changqin, and the 9 invited speakers who have shared their interesting work. Once again, on behalf of the committee, thank you for delivering such important materials so that all of us can deepen our knowledge about big data technology and application. Furthermore, I would like to thank all reporters and participants who have joined this conference from all over the world. I sincerely hope that through the presentation and the discussion afterwards, all of us can contribute to solving the big data, technology, and applications problems in our own country. Even though the contribution may be small, but it is still valuable. The next thing I would like to say, we are glad to announce the Best Paper Award. The Best Paper Award will be given to Yuan Shuai, whose paper titled Earlier Detection, the At-Risk Students in Online Courses Based on Their Behavior Sequence. Finally, ladies and gentlemen, I would like to thank all the committee members for organizing this conference and ensuring it proceeded smoothly. I would also want to apologize for any inconvenience that you might experience during this conference. There is a saying in China, all good things comes to an end. I hope you are joining the conference, and I also hope that we can meet again in the BDTA 2021. Thank you.